Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we're going to be looking at previous year questions of mathematics asked in engineering exams in India. Today we're dealing with the chapter Matrices and Determinants. So in this chapter we're going to be looking at the set of numbers present in square brackets arranged in rows and columns. This is known as a matrix. And then another operation matrix is called determinant. So we find determinant of a matrix and then we solve problems with respect to matrices that are equations and other kinds of matrices. So today we're going to be looking at some very important questions. Here comes the first. If A and B are square matrices of size n comma n, n cross n, that means n multiplied by n, such that a squared minus b squared gives you a minus b times a plus b, then which of the following will always be true? So is it a equals b, ab equals ba, either a or b is a zero matrix, or either a or b is an identity matrix? So in this question, what we're going to do is to find out which of these four relations are correct. So for this question asked in 2006, notice that both a and b are of the same order, n cross n. So therefore there is no difficulty in multiplying with them. So a squared minus b squared equals a minus b times a plus b. So therefore what we can do is we can now multiply the brackets on the right hand side. So a times a gives you a squared minus plus b times a gives you ba, minus a times b gives you minus ab, and then minus b times plus b gives you minus b squared. So therefore you have a squared minus b squared on the left hand side equals a squared minus b squared plus ba minus ab. So therefore when you take a squared minus b squared to the left hand side, you will get 0, and then on the right hand side it is ba minus ab. So therefore you can take ab to the right hand side, so therefore AB equals BA. So therefore, the correct answer for this question asked in 2006 is option B, AB equals BA. Now let's move on to the next question. Let A be the matrix 1, 2, 3, 4, and B be the matrix A, 0, 0, B. A and B belong to the set of natural numbers. Then, which of the following statements are correct? Now this question is again asked in 2006, and we need to find out the relation between matrices A and B. So it says that option A, there cannot exist any B such that AB equals BA. There exists more than one but finite number of B's such that AB equals BA. There exists exactly one B such that AB equals BA, and there exist infinitely many B's such that AB equals BA. So in all of these four options, you see that AB equals BA is taken as a condition. So therefore, it is we can safely assume that AB is equal to BA. So we have the matrix A and we have the matrix B. Now we just have to multiply them. So the matrix AB equals 1, 2, 3, 4 times A, 0, 0, B. So 1 times A plus 2 times 0, 1 times 0 plus 2 times B, 3 times A plus 4 times 0, 3 times 0 plus 4 times B. So therefore the matrix AB is equal to A, 2B, 3A, and 4b. So this is now the matrix AB. What about the matrix BA? So let's multiply that. So that is basically the matrix A0, 0, B multiplied with the matrix 1, 2, 3, 4. So now it is A times 1 plus 0 times 3, and then A times 2 plus 0 times 4, 0 times 1 plus 3 times B, and then 0 times 2 plus 4 times B. So therefore the matrix BA will now be equal to A, 2A, 3B, and 4B. Now we know that the matrices AB and BA are equal because in all the 4 options that is taken as a precondition, so we can safely assume that it's true. So therefore, since AB equals BA, then if we compare the matrices, it is A, 2B, 3A, 4B is equal to the other matrix that is A, 2A, 3B, and then 4B. So A equals A, 4B equals 4B, so there is no questioning that matter. But since these matrices are equal, you can safely say that 2B equals 2A and 3A equals 3B. Just taking out the common factors from both sides, you get B equals A and A equals B. So the numbers A and B, which belong to the set of natural numbers n, are equal. So when A equals B, you can write the matrix B, capital B, as equal to A, 0, 0, B. So that can be, so we can substitute B by A, so that is A, 0, 0, A. So A, 0, 0, A can be written as small a times 1, 0, 0, 1, which is the identity matrix for the second order. So A times I2 will be the value of the matrix B. So the matrix B equals A times the identity matrix for 2 rows and 2 columns. Now this is correct for all A equals B and A, comma B belonging to the natural numbers. So if you can have any amount, so from here, this statement, you can see that there is infinite matrices B. They exist for the relation AB equals BA. So therefore, if you are looking at our options for this question, then you can see that option D, there exist infinitely many B's such that AB equals BA, will turn out to be the correct option. So what we did is we applied the relation that AB equals BA. So we multiplied the matrices both ways, and then after multiplying them, we put in the condition, and then after putting in the condition, we noticed that the two numbers A and B are equal. So when A and B are equal, it forms an identity matrix. So even if A has any value, then B has the same value. So therefore, any of those values would satisfy the relation here. So therefore, there exists many infinite possibilities for the matrix B. So there exist many infinite B's such that AB equals BA is the correct answer for this question asked in 2006. Now let's look at the next question. We have a determinant given, and for x and y being non-zero, then we need to find out whether the determinant D is divisible by x but not y, divisible by y but not x, divisible by neither y nor x, divisible by both x and y. This question was asked in 2007, and in order to solve this question, we need to start working on the determinant. So over here, the determinant D equals 1, 1, 1, 1, 1 plus x, and 1, 1, 1, 1 plus y. So this is the determinant here. So as you can notice, we can easily convert the ones on the second and third rows to 0, and doing so would be to our advantage. So therefore, when we use the column transformation, C2 becomes C2 minus C1, and C3 becomes C3 minus C1, you would get the determinant D as equal to 1, 0, 0, then 1, 1 plus x minus 1 gives you x, 1 minus 1 is 0, 1, and then 1 minus 1 gives you 0, 1 plus y minus 1 gives you y. So therefore, this is now the current determinant. So now it's pretty easy, because when you have more zeros, then expansion becomes easy. So now what we do is we expand along row 1, the first row. So therefore, the value of D equals 1 times x 0, 0, y minus 0 times 1, 0, 1, y plus 0 times 1x, 1, 0. So the second and third terms can be entirely obliterated because they have a 0 multiplying them, so that they do not exist because they all become 0 in the end. So then 1 times xy minus 0 will be the value of the determinant. So therefore, the entire value of the determinant will be xy. So xy is divisible by x, and it's also divisible by y, because xy by x gives you y, xy by y gives you x. So that is simple division. So as you can see here, using our expansion technique, we found out that the determinant D is now equal to xy, which is divisible by both x and y. So therefore, the correct answer here is option D, divisible by both x and y, because this whole determinant, when expanded, becomes xy. Xy by x gives you y, x by y gives you x. So therefore, the determinant is divisible by both terms. This is the correct answer to the question asked in 2007. Now, we are in the final question of this episode. Let A be the matrix given. If the determinant of A square is 25, then we need to find out the modulus value of alpha. Now remember, although they have the same symbol, this is different. This is the determinant, because here we're asked to, because here the capital A is a matrix, so when this symbol is present before the letter of the matrix, then it's for the determinant. However, these two lines represent the modulus. So we need to find out the modulus of the term that is present in a matrix, which is alpha. So let's start solving this question. So now we know that A is 5, 5 alpha, alpha 0, alpha 5 alpha, 0, 0, 5. And we know that the determinant of A square is 25. So it would be a good idea to start from there. So we need to find out the actual value of the matrix A square. So that is 5, 5 alpha, alpha, 0, alpha, 5 alpha, 0, 0, 5, times 5, 0, 0, 5 alpha, alpha 0, alpha 5 alpha 5. So now let's start multiplying them. You have 5 times 5 plus 5 alpha times 0 plus alpha times 0. And then the second term would be 5 times 5 alpha plus 5 alpha times alpha plus alpha times 0. Now, on second thought, it would be a good idea to write it in the next page because it's too small for our requirement. So the matrix A square will now be equal to 5 times 5 plus 5 times alpha, 5 alpha times 0 plus alpha times 0. Next we have 5 times 5 alpha plus 5 alpha times alpha plus alpha times 0. Then we have 5 times alpha plus 5 alpha times 5 alpha plus alpha times 5. Next, over here we have 0 times 5 plus alpha times 0 plus 5 alpha times 0. And then in the second term, this is just multiplication of one row with one column. So 0 times 5 alpha plus alpha times alpha plus 5 alpha times 0. Next we have 0 times alpha plus 5 alpha times 5 alpha plus 5 alpha times 5. And in the last row we have 0 times 5 plus 0 times 0 plus 5 times 0. Next we have 0 times 5 alpha plus 0 times alpha plus 5 times 0. Now again, don't be panicked. This is just basically first row, first column, then first row, second column, then first row, third column, and then second row, first column, second row, second column, second row, third column. And now we're doing third row, first column, third row, second column, and then third row, third column. So that's the multiplication of each row with a column. So now we're doing third row times third column. So you will get 0 times alpha plus 0 times 5 alpha plus 5 times 5. So now we'll find out the value of the matrix here. 5 times 5 is 25. All of the other terms are 0. Next we have 5 times 5 alpha, that's 25 alpha plus 5 alpha squared. 25 alpha plus 5 alpha squared. Next we have 5 alpha plus 25 alpha squared plus 5 alpha, so that means 10 alpha plus 25 alpha squared. So next it's 0. Over here it's also 0, both those terms. Then we have alpha square in the middle, and then 0 here, and then we have 25 alpha squared plus 25 alpha. On second thoughts, it's actually 5 alpha squared plus 25 alpha, and then the last form will be 25. So now what we're going to do is we're going to take the determinant of this matrix. Now since the determinant of a square is already given to us to be 25, then this value 25 will be equal to the determinant, that is 25 alpha plus 5 alpha squared, 25 alpha squared plus 10 alpha, and then 0, 0, alpha squared 0, 5 alpha squared plus 25 alpha, and then 25. So when we'll now solve this determinant by expanding along the first column. So the reason why is because we have more zeros in the first column, so you only have to get this matrix, this determinant done, and the others can be equated off to 0. So then you have alpha squared times 25 minus 5 alpha squared plus 25 alpha. But then there's a 0 on top of this. So basically, this term also becomes 0. So now you have 25 times 25, that gives you 625, and then alpha squared. So 625 alpha squared gives you 25. So therefore, alpha squared is now equals 25 divided by 625. 25 squared is 625. So therefore, the simplified version is 1 by 25. So alpha squared is 1 by 25. So therefore, alpha equals under root of 1 by 25. Under root of 1 is 1. Under root of 25 is 5. So therefore, the value of alpha, the modulus value of alpha, can be written down as option A, 1 by 5. So for this question asked in 2007, 1 by 5 is the correct answer. All we had to do was to find out the square of this matrix and then find the determinant of the matrix, equate that to 25, and you'll get the value for modulus of A. So that concludes this question and this episode. So therefore, we hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.